Hey, we are continuing in our calculus class, and now we're going to introduce something new. But just to kind of show where we're going, we want to kind of look at where we've been. So calculus has two main problems or questions that we like to talk about. The first we've already answered, which is how do I measure the slope or the rate of change of a curve? And right here in the first graph, we learned this in algebra. If our line is straight, we have a slope formula for that. But if we have a curve, what we see here is the slope is different at different places. The rise over run, or the change in y over the change in x, is different as we move along the curve. And what we figured out was this limit definition of the derivative would give us the slope anywhere along this curve. But the second question is one we haven't answered. So let's kind of introduce it now, and then we'll see a little bit more about it later. But really the question is, how do I find the area under a curve? Well, on the first two graphs here, what we see is the area under a straight line. And what we could do here, is I'll do an example in a minute, is that we could kind of divide this up into shapes that we know. If we kind of cut this one across here, we might have a square and a triangle, which we know how to find the area of. This one here, we have a triangle. If we took the whole thing and we subtracted a smaller triangle, we would get what's left under here. So since those are our straight lines, we have figures for, or formulas for the figures they make. But over here in the last graph, we have a curve. So we don't have any geometric figures or formulas for area that fall under a curve. So this is going to take on a whole new life of its own. And what we're going to call this procedure that we're going to do is integration. Now it's going to take us a little while to get to integration fully, but what we're trying to do here is we're trying to figure out what this shaded region, this area, would be. Exactly, not a guess. Okay. Over here in these first two, not too hard to break them down into figures that we know, triangles and squares or rectangles. But because of this curve, there's no curve figures that we find the area of except for circles, and this definitely does not fit a circle. So we'll explore a little bit of the journey of getting to this integration of this area under a curve in the future videos.